Okay, it has started recording. They say a function reaches a maximum value when it stops increasing and begins to decrease. Meaning that, for example, as you can see here, when you start increasing, then it comes here, that's your maximum, then it starts decreasing. And they say a function reaches a minimum value when it stops decreasing. So it decreases, and then it comes here, then it becomes minimum. So as shown in this figure, right, we have maximum, and we have minimum, and minimum. Now they say from the sketch, it is clear that the slope, which is the gradient of a tangent to the curve at M and M is equals to 0. Why is that? Why is that the slope here of this tangent line that is drawn here is equals to 0? Because
it doesn't increase or decrease. There's no change.
yes, but there's a simple term. Why is that particular tangent line? Because remember, it's a line. Because we know that a horizontal line, its derivative is equals to 0. So meaning that if you have y is equals to 2, what is the derivative of that? That is dy over dx is equals to 0.
Derivative of a constant.
Yes, derivative of a constant is equals to 0. So meaning that if I draw a tangent line here, and then I find the derivative at this particular point, then I found the gradient of this tangent line at this particular point. Are you all together? Yes or no?
Yes, ma'am.
So now
Yes, ma'am,
if
I
I
think that's
find
fine.
the derivative of the entire curve, let's say this curve here is equals to y is equals to f of x, and I find the derivative, then this derivative, without substituting the value of x, gives you the general gradient of all these tangent lines that you can draw on this curve. Does it make sense?
Yes, ma'am.
Yes, ma'am.
Now,
Yes, ma'am.
as soon as you substitute the x value, you then get the gradient at a specific of a tangent at that specific x value. So if this one, its x value was -5, if I go into this derivative and substitute -5, it will give me the slope of this tangent line. If I go and take a point here, which is 1, take the derivative, it will give me the slope of that tangent line. So now they're just telling you that the maximum and the minimum occurs when the derivative, the first derivative, not the maximum, where the first derivative is equals to 0. That's where the maximum or the minimum occurs. Now, so they say when we solve the equation, you go and read up there. So when we solve the equation dy and dx, we get the value of x, which makes y the minimum or the maximum. So we get the value of x for which we can get the maximum or minimum. And remember, because when we are reading maximum and minimum, we're looking at the y values, the height. So from here to here, from here to here, and from there to there. So meaning that at this point, when we find the derivative, we equate to 0 and so for x. Then we get the values of x. Those values of x, we then have to do something to check whether this value x1, let's say x1 is 5 and x2 is equals to 7. We then go and substitute somewhere to check which one is the maximum or which one is the minimum. Once we are done checking which position represents the maximum and which position represents the minimum, we then go take those values of x and substitute into the original to find now the maximum value or the minimum value. Are you all together? Yes or no?
All right. Yes, ma'am.
Okay. So now you'll go and read this part, right? And me, I come here. Now they say the function y reaches maximum when the second derivative is less than 0. right? I want you to go and read. We'll do the example. This is the second one. And then they say the function reaches a minimum when the second derivative is equals to what? I mean, it's greater than 0. So we'll be looking at examples there. Let's continue. Now, the point of inflection. What is the point of inflection? A point of inflection is defined simply as a point on the curve at which the direction of the bending changes. Did that make sense, guys?
Can we have a little bit more elaboration, ma'am?
Yes, ma'am.
So for example, if I'm drawing a curve like this, like look at P. Do you see that P, it goes like this, and then it changes, it bends somewhere like that, the direction of the bending. Look at that. So this is the point of inflection. Look at Q. It is open, 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 and then at some point it then closes. This is Q. That's the point of inflection. Inflection. Flexion. Yes,
Okay.
that's what they say. Now, let me see if I want you to go and read. Okay, let's just read this together. P and Q are points of inflection. At P, the gradient is 0. Do you all agree that at P, the gradient is 0? Look at the dotted line.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, I need 3 yeses. Did I get 3 yeses?
Yes,
Now
ma'am, I
at
think
Q,
that's fine.
now at Q is the gradient equals to 0.
No.
No.
So meaning that you can't use the first derivative to determine the point of inflection. Why? Because at P, the gradient is 0. The first derivative is 0. At Q, the first derivative is what? Is not 0. So meaning you can't use the first derivative to find the point of inflection. So they say the gradient, at P, the gradient is equals to 0, meaning that the derivative, the gradient of the tangent line, this dotted line there that touches the curve once, is equals to 0. At Q, the gradient is positive. That is dy over dx is not equals to 0. The first derivative can therefore not be used to find the point of inflection. So to find the point of inflection, we have to differentiate the function twice. And then now we solve for the second derivative equals to 0. Then we check for a change of sign in the second derivative as we go through the point. Does it make sense what they're saying?
Yes,
Sorry,
ma'am.
ma'am. Are you saying we can't find the point of deflection at P only, or is this
We
a
are saying
combination?
that
Okay.
we are
okay.
saying that we can't find a point of inflection by using the first derivative because remember the first derivative represents the gradient of a tangent line touching at a particular point in that curve, one point at the curve, right? Now, if for P, it was a horizontal line, and for Q, it was also a horizontal line, then we could use the first derivative. Just like when we had in maximum and minimum, look at this. All the gradients in M and the small m, do you see all of them? The first derivative is equals to 0. Do you see that?
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes, the first derivative is equals to 0. That's why we're using the first derivative equate to 0 to find the point at which the the minimum as well as the maximum what's this appear. Do you see that? Or the minimums appear, or let's say maximums or minimum. But now this is not the same when it comes to the point of inflection because look at Q. Now, when you go and draw a tangent line at Q, you see that the straight line here has a positive gradient. It's like this. But at P, it's like this. Meaning that for different, let's say if the bending was like this, I'm not good at drawing, guys, you know that. If the bending was like this, and you were to draw a dotted line to touch this graph like this once, the bending is here, once there, then the gradient will be negative, meaning that you might have positive and negative gradients, but you don't have a horizontal line. That's why we're not using the first derivative. We're going to use the second derivative to find the point of inflection. And when we need to consider whether it changes sign or not, but then they will look at in the examples. Are we all together to that point?
Yes, ma'am, it makes sense.
Okay. So now they're saying the procedure is used the following procedure is used to find the maximum and the minimum values and points of inflection. Let's look at this. I'm going to do one example for each, and then you do the remaining. Let me minimize. I want you to look at the question and then we go and discuss. I'm giving you 2 minutes. You can discuss. What do we do first? What's the second? What does the second step mean? What does the third step mean? And then after that, we do the examples.
There's nothing on the screen, ma'am. Oh yeah. Can you scroll a little bit up, ma'am, so that we see what that box is intending? The following. Okay, thank you.
Guys, no one is saying anything.
Okay.
Okay.
All right. So, is there anyone who's not understanding step 1, step 2, and step 3? Because I
Step
wanted to ask
one.
about like step 4. Step 4 we can use tables, ma'am. Like instead, if I don't wanna like pick, like, I can just like use tables to see like how my function is behaving, basically. When I'm testing the point, I just say plus, minus, and then like that function in the other side when it's reached, like on the second derivative or on the points of the critical points. But
So
that-
step 4, sorry, Ben.
no.
No, I'm saying so step 4
Yeah.
will. Now let me let you finish, sorry.
No, like, is there anyone who's not understanding step 1, step 2, and step 3 before I talk about step 4? That's what I'm asking.
Can we maybe just start at step 1 and then go systematically down to step 4? In case someone's a bit too shy to say they don't understand step 1, 2, or 3.
All
Yeah.
right. That sounds fine. So step 1, we're basically finding the critical points, right? So where
Okay, the screen is
slope of
gone. The screen is gone on my side.
Maybe your screen disappeared.
I think I left the meeting by mistake. Okay. Can you see the screen now?
Yes, we can.
Yes, ma'am.
Yes, yes.
And let's not have only one person or 2 people. Let's have 5 people discussing. And more. 5 and more. So what
All
is
right.
step 1 saying?
Basically finding where the slope of the tangent is 0.
We know that.
So this is what I was asking previously, like where you said the gradient there won't be 0. Is this where we check on step 1?
Yeah, the
Step
first
1.
derivative.
Yes.
Okay.
So for step 1, they say the following procedure is to use to find the maximum and the minimum values and the point of inflection. So we're assuming that step one, remember we said that for us to find the x values from which the derivative is equals to 0, where's the derivative first? Equals to 0 here. Do you see that? Which is
Yes,
the
Yes, ma'am.
derivative equals to 0. This is where the derivative equals to 0. So meaning that if we are finding the derivative dy dx is equals to 0, we are finding the x values where the derivative is equals to 0. Meaning we are finding the x value here, the x value here, the x value here, and the x value here, and the x value here. So that's what we are finding for the first step. Are we all together?
Yes.
Yeah.
Yes.
Yes, yes.
So we're saying, all right, we are drawing it like this. We're saying here, we know the tangent line is a horizontal, the tangent line is horizontal. So we know here the derivative is 0, here the derivative is 0, here the derivative is 0. So if we find the derivative equated to 0, and so for x will give us the x values here, x values here, and x value there. Now that we have the x values, do we assume that x1, because it's positive, is a maximum? Or do we, for example, x is equals to 1 and x is equals to 5. Do we assume that x2 is equals to 5? Do we assume that x2 is the maximum because it's higher than x1?
No,
No,
So
ma'am.
No,
do we-
no.
because it tells you nothing about the change of the gradient. It only tells you the position of x.
Thank you. So what do we do then? We go to step 2. What do? We find the second derivative, substitute the values into the second derivative. So meaning that what we go is we look at the second derivative, take those x values, x1 and x2, put them in the second derivative. Now, if whatever value you find in the second derivative is less than 0, meaning that in mathematics, we know what does less than 0 in mathematics mean? You guys are not first years. I know you know this. Less than 0. What does it mean?
It's negative.
Thank you. So it's negative. So they're saying that if the derivative, the second derivative, given, let's say you put x1 in it, in the second derivative, you find that it's negative, then that point of yours is a maximum. It's the position, let's call it the position of the maximum point. Does it make sense?
Yes.
Yeah.
Now, for the second derivative, if it's positive, then that gives you the minimum point, where the minimum point lies. Now, since you get the maximum point and the minimum point, how do we then find the minimum and the maximum value? What we do is we take the same values, substitute them into the original function, that one that you differentiated before differentiating the first function to determine the maximum value or the minimum value of y. So are we all okay with finding the maximum and minimum?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
Now,
ma'am.
and we say the point of inflection is where there's a bending, right? So they say, okay, fine. Remember, we can't use the first derivative to find the point of inflection because we notice that P and Q, their gradient, the first derivative is not equals to 0. So we then go and find the second derivative. We solve for the second derivative, so for x. After getting the value of x, we test with a point just before x and a point just after x, whether there is a change in sign of the second derivative to establish the point of inflection. Does that statement make sense?
Yes, ma'am.
Yes, madam.
Yes.
Yes. So what does it mean? Simple English. What does it mean in simple English, guys? You guys said yes. Guys,
I
give me
think
simple English. Yes.
Isn't it where it goes from positive to negative second derivative or negative to positive second derivative?
Okay, so if you were to tell a 5-year-old,
Does it
what
go
do
from a
you,
plus to
I
a
will use
minus or
I will use
minus
that
to a
one, I
plus?
think.
but then they're like, what goes? What do I do first? Yes, it goes, but what do I do first if I were to find the point of inflection?
Set the second derivative to 0, then solve for x.
Yes, then
Then what I get from the values of x, I would then, like if it is, let's say 5, I'll take
yes.
maybe I'll take 7 and I'll take -1 and test.
Then
I see if the changes of sign. So if it is like, if like maybe my graph was like a sine graph.
there's no graph here. There's no graph here.
Okay.
You have a -7 and a 7
Okay.
and a 5.
If minus is changing to positive, or if the positive is changing to negative, if there's no sign change, I'll test the sign change, like if the sign is changing or not.
Yeah, let's go to the examples. Find the maximum or minimum. Find the maximum, guys. Even
But
if you're
maybe
not
we cannot go forward, Galog, before you explain. We can't move.
Me, I was told I'm spoon feeding, so I'm not going to spoon feed my
You already
second.
did the spoon. You already did the spoon feeding from step 1 to step 3. So just finish it.
Let's go to examples and see. Find the maximum and the minimum value of a function. Here's a function, guys. And remember, for as much as you guys, some of you will be teachers, some of you will have to teach your daughters, your sons, your nephews, your nieces, and your neighbors and aunts, and whoever is going to learn maths one day. So let's learn to explain. Come on. You have this function. What's the first step?
Is derive the first derivative of the function.
Okay. So y, are we choosing a color, guys? Or should I stick with black?
I'm feeling colorful. Can we make it green, or is that too?
I like green.
All right.
We don't
Anything
have
that's
color blind.
visible, as long
We
as
don't-
it's visible.
Okay. We don't
Yeah.
have a colorblind male person in our class, right? Okay, no problem. So then we have y is equals to 4x cubed plus 3x squared minus, I'm even going to try to make my handwriting very nicely because this will be my last class for study guide 1 up to the next part. Now they say you find the first derivative. So dy over dx is equals to, give me the answer,
12x
please.
squared
12x
X squared
Yes.
plus 6x minus 90.
Okay, then what?
Then you solve.
Then you equate it to 0.
equals to 0, then we find
You first equate it to 0. Dy over dx equals to 0. Then you say dy over dx is equals to 12x squared plus 6x minus 9. Can you please give me 100% on such questions, guys? So that when I mark, I'm even proud of you for getting 100% in one question. I become proud, by the way. Equals to 0. So then we have 12x squared plus 6x minus 90 equals to 0. Let's hear it. No calculators. No calculators. Let's try.
Let's divide by 6 on all sides. Or do you want the final answer, ma'am?
Oh, divide by 6 both all sides. So we're left with 2x squared plus x minus, what is 6 divided by 90? 90 divided by 6.
It's 15.
All who I taught in first year must be very sharp here because they were not using calculators. Come on, then we do what?
Then you factor.
How?
Factorize.
Factorize.
Wow.
It's 2 and 1 and 5 and 3.
2 and 1 and 5 and 3.
And the sign should be different. So let's just open the two brackets, put a minus in between one of them and a positive in between the other.
Okay. Then
It should be x plus 5 and 2x minus 3.
are we all okay with the way of factorization? Guys,
I'm fine, ma'am. Thank you.
can I have three another fine?
Positive.
Yes, ma'am.
Okay. If you're fine, it's okay. Let me check. Are we all okay? Is the answer correct? Then I won't show you how I do it. Is the answer correct? Is the factorization correct?
Sorry, ma'am. Sorry, ma'am. I
No.
think
Yes,
the factorization 5 has to go with 2x minus 5.
2x minus 5.
Yes, I think so. 2x minus 5, ma'am.
Hey, son. And you guys said you are okay with the factorization.
2x minus 5.
2x
then
minus 5. Hold on, let me
X
cross
plus 3.
multiply.
Yeah, 2x minus 5, x plus 3. Yeah.
Okay, let me continue. 2 times 5. What am I saying? 2 times 15.
It's
I mean 2
30.
times negative 15.
Negative 30.
Negative 30. What are two numbers such that when I multiply them, they give me negative 30, but when I subtract them because of the minus, they give me x. I mean 1, sorry. 1 here. Positive 1.
5, 10, 15, 20, 25, 30.
5
Minus
and
6
6.
and 5.
Which one becomes positive?
6 and
5.
5.
Sorry. That is positive. So 6 becomes
6.
positive, then 5 becomes negative.
And which one is easy to factor with 2? And which one is easy to factor with 5?
6 goes with 2, then 5 with 15.
Well done. So this will be 2x squared plus 6x minus 5x minus 15. Now we then do groupings. When we do groupings, we group such that everything in the bracket is the same. So what do we factor out for the first part here?
2x.
X. Open bracket. Then we remain with what?
With x plus 3.
X plus 3. What do we factor out here such
Minus
that
5.
we also have x plus 3 inside?
Minus 5.
Minus 5.
Minus 5.
Thank you. So it's minus 5. So then we take this and this together. So it's 2x minus 5, and then x plus 3 is equals to 0.
Yes.
Now we are all okay, isn't it? So we are factored properly.
Yes, ma'am. Yes.
Thank you. So then we have x is equals to 5 over 2, or x is equals to negative 3. Now we are done. We found x, we found y. What's the next step? What am I saying? We found both values of x. What's the next step?
We differentiate the equation we just differentiated the second time.
Thank you. So this is the first one. So let's go differentiate. So we know that our first derivative, dy over dx, the pen is changed, dy over dx was equals to 12x squared plus 6x minus 90. So the second derivative, d squared, what am I saying? What is my brain saying? Y over dx squared is equals to 24x plus 6.
6.
Then what do we do?
We substitute our x's.
Thank you. We substitute our x's. Why are we substituting our x? We have 5/2. Why are we substituting our x?
To test each point.
Because
Thank you. X squared. So 24. 5/2 plus 6. What is the answer there?
60, ma'am.
60. Guys, you guys are second year. You are allowed to use a calculator for this module. What do you get?
66.
66. 66, ne? Yeah, 2 into that is 12. 12 times 5, that's 60 plus 6, 66, yes.
So what can we conclude with 66? This is a?
Positive.
So it's
Minimum.
greater than 0.
It's greater than 0.
So this is not the minimum. This is where the minimum exists.
Oh, okay. Got you.
Minimum. Are we all together, guys?
Yes, ma'am.
X is equals to -3, right? Now we then substitute. I think I now know what I'm going to say to you. So it's 24 minus 3 plus 6 is equals to?
It's 66.
Minus 66.
Which is less than 0. This is where what? The?
Maximum.
Okay, thank you. Then step 3, what do we do?
And the inflation point, isn't it?
Step 3, what do we do?
Wait. Step 3 is equal to 0, I think.
Don't we find the maximum and minimum in the y values?
Thank you. Remember I said the x values, they give you the point
X.
where the minimum is and the maximum is, but they don't give you the minimum and the maximum value. So to find the maximum value, you then say, okay, fine, I know that my minimum exists at what? At x is equals to 5/2. So then my minimum value, meaning, am I getting a question? What do I do with the minimum value? I go and substitute. Let's call it y min. Please mute. I then substitute there and say 5/2 into the original. Then what do we get?
One over 4.
1/4. Let's put it into decimal so that we can see. Oh, but it's still fine. What is 1/4 in decimals?
0.25.
Now we go, okay, okay, fine, because our maximum value occurs at x is equals to 3. And now with this, we're expecting that when we substitute x equals to 3 into the original, the value has to be higher. If it's lower than this, then something is wrong because it's telling us that our maximum value occurs at x equals to 3. So let's do that. So maximum value, which is y max, is equals to 4 -3 cube plus 3 -3 squared minus 90 -3 plus 144. What is the answer?
333.
So then that's how we find the maximum and the minimum. Are all okay there?
Yes, ma'am.
I think I might decide the reward. Right now.
Is it money?
No.
Yeah.
I almost went broke last year. I almost.
20 marks.
No, I can't give you 20 marks. That's too much.
Just time 24 life.
Yep, I can't. Okay, let's go to second question. I'll decide. Let me decide. So here they're showing you how the graph looks. This is how the graph looks. Let's do this one. Okay. Today I'm releasing you early. Don't worry. So they say find the maximum and the minimum. So we have y is equals to x to the power of 5 minus 5x to the power of 4 plus 2. First step, what do we do?
You do the first derivative.
The y over the x, which is equals to 5x to the power of 4 minus 20x to the power of 3. Then what?
We set it to 0, ma'am.
Thank you.
Correct.
Then you say dy over dx is equals to 0. Then we say, okay, fine, dy dx equals to 0. Then we have 5x to the power of 4 minus 20x to the power of 3 is equals to 0. So we factor out. What can we factor out here, guys? I'm assuming you know what to factor out.
Five.
Yes,
Five X. Yeah.
Are we done from here?
Then you do the second derivative.
Alrighty. So the second derivative is equals to
20x cubed minus 60x squared.
then what do you do with it?
You factor out 20x cubed.
Why are you
equals to 0.
Set it to 0. Factor it
Set
out.
it to 0.
Oh, yes, I forgot to set it to 0, yeah.
Why are we setting it to 0?
Ma'am, we substitute our x values into the second derivative.
Why are we substituting our x values into the second derivative?
That was the next step, wasn't it?
To check the maximum and minimum.
Thank you. To check. Guys, you need to know why are we doing it. The first step is to find values of x for where the maximum or minimum lies. The second step is to check those values of x, whether it will give me a maximum or minimum value. And the only time to check that is finding the second derivative. You see. So then find the second derivative and substitute. So let's start with x. X is equals to 4. What is the answer? Sometimes they're saying x equals evaluated x equals to 4. What is the answer?
People with calculator, please come on.
320.
I don't have a calculator. My modules don't need a calculator.
But this one you're allowed to use a calculator, guys. Is it 320 the answer?
Yes, ma'am.
Okay. Let's do x is equals to 0. This line
Zero,
just
ma'am.
says evaluated
It should
x.
be 0.
What can we conclude? Did they say anything about that?
No.
We didn't conclude here. Greater than 0, it means what? Minimum, right?
Minimum, yeah.
Yeah, and lesser
So we
than
don't,
is
we don't
maximum.
have maximum, ma'am.
No, we do have. So what we do is we go and find the second derivative, the third derivative.
Oh, okay, okay.
Yes. And then what is the third derivative in this case? It's what? It's
The
20.
60x squared?
Thank you.
60x squared.
Minus 120x.
Okay, because this is the only one that is inconclusive. So let's go and substitute and let's see. Evaluated at x equals to, what do we get?
0 again.
So what do we do then?
We'll take the fourth derivative.
Thank you.
Wait, are we really going higher?
Yep.
Yeah. So the more you're taking, it's like basically what you're doing is the tangent line. You're dealing with the tangent line. You just want to a point where you can find a maximum or a minimum. But as soon as you're finding the what's this? Only 0, 0, zeros, then you need to get to a point where you get a value. So meaning that you can do 100 derivatives for some functions until you get a value. As long as they give you 0, then you can't say whether it's a maximum or minimum.
Yeah.
Yes. So then the fourth derivative is what?
120x.
120.
So then the answer, when we substitute, we get what?
Minus 120.
Minus 120.
Thank you. So then we conclude something there. Minus 1. This is where we find the maximum.
Maximum.
So then it means that at x is equals to 0, we find the maximum, and x is equals to 4, we found the minimum. So how do we find that maximum and minimum then?
We evaluate the y value.
Thank you. We evaluate it to the original. Control V, what was the original? So then we say x.
It doesn't matter that we found the minimum, the maximum, sorry, the minimum at first derivative and the maximum at maybe 10th derivative. It doesn't matter. You just use the values that you got.
Fix it. Fix the problem. We did not find the maximum at the first derivative. We did not find the maximum at second derivative. We found the position where we can find the maximum.
Oh, okay. Okay, it's about the position. Okay, thank you so much.
It's about the position where we can find the maximum. So x1 and x2 are positions where we find the maximum. Then we check at x1, do I find a maximum or minimum? At x2, do I find a maximum or minimum? That is the second derivative. Right? Then after, we then go and say, okay, fine. This point, this is where I'm going to find my maximum. This point is where I'm going to find my minimum. According to us, we said that x is equals to 4. We're finding our what? That x is equals to 4 is the position where we'll find our minimum, isn't it? So then we say 1 minimum is equals to 4 to the power of 5 minus 4 plus 2. So the answer is what there?
Negative 254.
Negative 254. Now, at x is equals to 0, we said we find our maximum. And it means that it should be greater than this value. That's what we are saying. Plus 2. So the answer is 2, which is true. So 2 is greater than negative 254. And that's how we find our maximum and minimum. Are we all okay? Am I stressing someone?
So yeah. So we don't use the actual position we found the maximum here. We use the first one, like where it was 0.
Extra position.
Or am I missing? I think yeah, where the answer was minus 120, I think.
So listen again. What is the first step to find the maximum or minimum? What is the first step?
The first step to.
Isn't that you differentiate?
Yeah,
right?
you differentiate. Okay, yeah.
When you are differentiating, it gives you the position.
Yeah, I get that, but then what I'm saying here is when you do this substitution, do you use those values you found where you are saying is the position?
Yes, you always
Unless-
use the x and the x values that you got. But you
Oh,
have
yeah.
to show
Okay.
that
Okay.
x1 is x equals to 4 is a minimum, and x equals to 0 is a maximum. X
Okay.
equals to 4 was easy to show. X equals to 0, we had to differentiate and differentiate and differentiate
Yes.
to see. Yes.
Okay,
Once
what
we
I'm
have
not getting, okay, what I'm not getting, ma'am, is
Mm.
the value there was x is equals to 4 because
Yes.
you're able to differentiate, but then the position that we ended up with was 120, I think.
That
When you
was not
went
the
down
position.
okay. I think this is what I'm missing.
That was not the position. Do you understand? That was not the position.
Ma'am, can I
Okay,
help?
let's do the
I think-
language part.
I
Before
think
that,
he's confused
Yes?
about the outcomes that we got on the second derivative. I think that's his confusion. He wants to substitute those values into the main.
we're not substituting those values into the main. We're not substituting. Who was speaking?
Oh,
The
yes,
gentleman was
it's
speaking.
it's Mahato. Yeah, it's me. So you were substituting the first values you got when you did the derivatives.
The first derivative.
Okay.
Yes. I hope
Okay.
it's clear to everyone, guys. If it's not clear in Isikhoa and or in English, Isingis, I will explain in another language.
Do it in Zulu,
No,
man.
it's clear, ma'am.
Do it in
No,
Latin.
it's clear,
ma'am.
ma'am.
I know Latin, I don't know it. I'll only sing Roman Catholic songs in Latin. Okay, no, that's good. So just remember, guys, the first time, remember the first step, dy over dx equals to 0. X is equals to 5, and x is equals to 2. Those are positions. So you go and check them. Are they maximum or minimum? Whatever value you check at the second derivative doesn't matter. As soon as you are done proving that they are maximum or minimum, you take the same x values and then go substitute in there. Now, this time you mentioned that it's a minimum or it's a
Okay.
max. The y value that you
Okay, then
find, yes.
yeah, I get it now, ma'am. But I think my problem was because you did too many derivatives for the other position. So I was confused as to whether you used the first one where it was 0, or are you going to use the actual position that you found with all those derivatives that you were doing.
Okay, so all those derivatives are like this. You see, isn't that we get x is equals to 5 or x is equals to 2, right? Then we take this x equals to 5 equals x equals to 2. We go to the second derivative. We substitute. Let's say for 5, we get the second derivative equals to 0. We go differentiate the third derivative because 0 doesn't mean anything. We substitute again 5. We get 0 until we get a value for x equals to 5. Once we get a value, then we can say maximum or minimum. Then you can then go up and substitute into the original. I hope we are all
Yeah,
together.
but then you will use 5 instead of this. Okay. Okay. Okay.
Okay. Are we all together now? Can I move on? Move forward.
Yes, ma'am.
What is 5 out of 1? Okay. That was not a right answer, a question. I think I wanted to decide on the price to give for the memos. We'll negotiate after. Do you want to go through the step of point of inflection, or you can find point of inflection by just do you want to go through the steps again? You go through the steps again. Or should we just do the question without the steps are still in your mind? My good people.
Now we can do the question.
Okay. So let's find the point of inflection. If any of the function does. What do we do? Point of inflection, what do we do? Guys,
Yes, ma'am.
What?
First derivative.
you guys said you are okay. Point of inflection, what do we do?
We do all the steps for the maximum and minimum. Then the last step, that's when we find the inflection.
All the steps.
Not all, but some of them, the starting ones, not all of them.
Which one? Let's start.
Okay,
Step one.
let's do the shortcut. We can find the second derivative, ma'am, of the function.
So we find what?
The second derivative, because the what do they call inflection points works with the second derivative.
Thank you. The point of inflection works with the second derivative. So the first step is to find what?
The second derivative.
Let's find
Okay,
the
first
second
find
derivative.
then the second.
You first find the first derivative. How do you find the second derivative without finding the first derivative? So dy over dx is equals to what? 3x cubed over 3 minus 2x squared over 2 minus 2. So this is equals to x cubed minus x squared. Hi, guys. You're not even telling me I'm wrong. You would tell me in the comments of the class. Guys, differentiate my
The
brain is
problem
not-
you are complaining one moment, you are spoon feeding us. Second thing, you are going on.
Okay, sorry then. Let me not spoon feed you. Give me the derivatives because my brain is shutting down.
X squared minus x minus 2.
Thank you. So this is 3 squared over 3 minus 2x over 2 minus 2. So it's what? X squared minus x minus 2. Is it
yes,
correct?
Yes,
Thank you.
Yes.
The second derivative?
It's x squared minus x minus 2, which is equals to 2x.
Huh? What
It's
did you
2x minus
2x minus 1.
2x minus 1.
2x minus 1.
That was Latin. 2x minus 1. Then what do we do with the second derivative? What do we do with the second derivative?
We equate it to 0 to find the
Danko. This implies that x is equals to 1 over 2. Then what do we do with that?
I think that's what we check for
the normal equation.
We check.
Madam, we substituted back into the original equation.
So if we substitute back into the original equation, what are we doing?
No, we test for the points, ma'am. Are we not supposed to do the
Yes.
points?
We don't substitute back into the original. We test
test
for
for
the
the
points.
sign
Don't we set it to 0 or
No, now we are taking for the sign change. We put like -1 or 1. So 1 point before half and 1 point after half. That's the fourth step most.
Do we agree, yes or no?
Yes, I agree.
Yes, ma'am.
Ma'am, can you please explain that again?
We're looking
So
for
you
sign
said-
change now. Inflation points works with sign change.
So remember the point, what's this? The inflection works with the bending, where it bends to the different direction. Like if my graph was going like this, and then it starts to go up. So this point here, where it starts to bend, where it starts to, here it was decreasing, it was concave down, and here it's concave up. that point of inflection is the point where the bending changes, right? Now, it means that here, if we substitute before the half, any value before half, if we get positive and take any value after half, if we get, okay, let me say x is equals to 1. If I take, what is the value before x equals to 1? Let's say -1. I substitute and I get positive. And then I take the value after 1, which is 2. I substitute and I get negative. Then x equals to 1 is a point of inflection. So meaning that in this case, we need to get values before, values before 1/2 and values after 1/2 and substitute. If there's a change of sign, if the sign says the answer is positive, both of them, then there's no point of inflection. But if the answer is the same, if the answer, the signs are different, one is negative, one is positive, then it means that's the point. X is equals to half is a point of inflection for this particular graph here. Do you see that?
Oh, I get it now, man. Thank you.
Yes. So then now we need to go and choose the point. Now my worry is in the exam, I cannot go and mark 800 points. So what do we do? As half mathematicians, engineers are half mathematicians. Not half, but as a little bit of mathematicians in you. The mathematician in you, what is it saying? How do we generalize it? Guys?
Or the use of a table.
Huh.
Give us the marks anyway.
You can choose a variable, guys. Remember, a variable represents any number.
Okay.
You can choose a variable and make it positive. So in this case, in our study guide, they chose A. So if I choose A and I assume that A is positive, right? So A represents any number. Now, if I say X plus, if I have, let's say X1 is equals to, I have X, sorry, not X, a value, okay. I don't know why am I just down. I think I'm tired. Now, if A is positive, a value before half, do you agree that it will be 1/2 minus A? Guys?
Yes, ma'am. We see that.
Now, since A is positive, a value after half will be X2, which is 1/2 plus A. Do you see that? Instead of choosing a value, because all of you guys will be choosing a different value. And I can't go and calculate to check whether you're right. So you need to always generalize it, right? So what you do is, you then take this new value and substitute it in here, right? So then we have d squared y over dx squared, which is equals to 2. This is before. The value before A, which is this one, right? So then this is 1/2 minus A minus 1, which is equals to 2 times this is equals to 1 minus A minus 1, which is equals to minus A, right? Now, we said A is positive. Do you see that? Guys?
Yes, ma'am.
Yes, ma'am. A is greater than 0.
Yes, ma'am.
Yes, so meaning that the answer is minus A. So meaning our answer is negative, isn't it?
Yes,
Yes,
yes.
ma'am. Okay, yes.
So
yes.
then you go and check the value after half. After half, we represented it as half plus that. So that's d squared over dx squared, which is equals to 2, 1/2 plus A minus 1, which is equals to what? Now we know that this times this is 1 plus A minus 1, which is equals to A. Do you see this one is minus A and this is plus A?
Yes, ma'am.
Therefore, the sign has changed. If the first one was plus A, the second one was minus A, the sign have changed. Since the answer here is positive and the answer here is negative, they are not the same. Therefore, you say X is equals to 1/2 is the point of inflection. Sign. And that's the point of inflection. Does it make sense?
100% yes.
Yeah, don't sign. In the exam, don't sign, guys.
Why not? We just signed.
So that's how you find the point of inflection. Now, I will only discuss the reward of recording.
No camera, I know.
Yes, I always do that. Okay. Now let's look at the last. I'm going to choose one question. There's no more question, isn't it?
There's someone who raised their hand.
Okay, please speak or forever hold your peace.
Oh, ma'am, I was just asking, which method do we use actually that is safest? Is it that we are using the variable, or we can just choose the value actually?
You can choose the value, but I don't want you to choose all of you to choose because there's 800 of you. So imagine all of you choosing different values. Just generalize it. You see, and it looks like even
that we should stick to.
You see, even the example, choosing a point before, they just generalize it. You always do plus A minus A. Do you see that? Even you see? I'm just looking at this question. You see? Point before. So they are generalizing it. Just do plus
Okay,
A.
thank you, ma'am.
Yes. So that it's not trouble for you as well. Hey. And then at the end of this learning unit, you should be able to apply differentiation to practical problems. Guys, here's a problem. Here's a problem. Let's solve it. Help me to solve. We'll do one example here and the rest you'll do it. And I want questions. I want questions. Guys, are you still there? Or should I leave this one? You'll do it on your own, eh? This section.
No.
No problem.
Okay, let's do this one so that you get an idea of what they say. They say the acceleration of the piston of the reciprocating engine when the crank makes an angle theta with the horizontal is given by the formula this. I don't even know what they say today, but I see there's an engine and there's a piston. Tell me what they say, guys. You guys are engineers. You should be telling me what they're saying. Hmm? Or you don't know as well? Guys, and then we can close the class and then you'll do the question by yourself.
No, ma'am, no.
Hey, don't say, man. Hey, some of us are not mechanical. Where are the mechanical people? You guys study this engine thing? Explain.
No, we are first years. We haven't reached that part already.
Okay, let's because it's in the math module. Let's try to solve it then. We assume that we know what an engine is and how it looks like. And then they say that, okay, fine, makes an angle theta with a horizontal. It is given by this formula. So this is the formula that we get. Right? Now they say where A is an acceleration, where this is not, is this double, let's call it double angular velocity, of a crank, which is positive, the radius of a crank, which is positive, and the length of connecting rod divided by R. In practical, N has to be greater than 4. Now they're saying that find the values of theta for which A will have a maximum and a minimum value. Where do we start?
We take the first derivative, man.
You see, even if we don't know what the piston of the reciprocating engine is, but because we know our maths and we understand our work, we take the first derivative, right? So we take the first derivative with respect to what? We take the first derivative with respect to what, guys? Because there are so many variables.
To
Theta.
Theta.
Thank you. We take they say find the values of theta, meaning that we take with respect to theta, for which A will have a maximum and a minimum value. So we go and take the first derivative. So let's do that. So then we know that dA of, they said green. So then we have dA over d theta is equals to, should I spoon feed you? W squared R negative sine of theta plus 1 over n negative sine 2 theta times 2. I'm assuming you know these derivatives, guys, is equals to WR that, okay, let me put like this. I don't know why my eraser is no longer erasing. Okay, let's see. So this is equals to negative W squared R sine theta minus 2 over n sine 2 theta. Am I right or I'm wrong?
You're right.
Yes, ma'am, you're right.
Yes, ma'am.
Okay. Then what do I do with this now? What do I do?
We set it equal to 0.
Thank you. So then why am I setting it equals to 0?
So we can find the values of theta, ma'am.
Thank you. So then minus W squared R sine of theta minus 2 over n sine of 2 theta equals to 0. Then what do I do? Please help me.
We can have a look at factorizing it, ma'am.
Okay, so what am I factoring out?
Sine theta, ma'am.
There's something missing, guys, here. Do you see that?
Yes, ma'am. You didn't multiply the W squared R to the other term.
Thank you.
Yeah.
Thank you. So we factor out sine theta. Do we factor out sine theta, guys?
No, it would probably
I
be
think
better to do
WR
W.
squared.
Yeah,
squared.
W squared R sine theta.
WR squared sine theta.
Ma'am, if we can change the sine squared theta to a double angle first, like 2 sine theta cos theta.
Okay. So you're saying that, yeah, what have I done? Freak it out. Ooh, I'm even swearing in class. Ooh, I've destroyed our work. Okay. This is 2W squared R over N sine 2 theta. So someone is saying, okay, we have dA over d theta. We equate to 0. So this implies that minus W squared R sine of theta minus 2w squared r of n. Then we have sine 2 theta equals to 0. What is it about the double angles? Please repeat.
So the sine squared theta, the second term sine squared theta, when we change it because it's a double angle, it's going to be 2 sine theta cos theta with the rest of the term.
Well done. Are we all together in this boat? Yes or no?
Yes, ma'am.
Yes.
Thank you. So then what do we factor out now? So this becomes minus WR sine of theta minus 4W squared R over N sine of theta cos of theta. Just because you're not first years at UNISA, don't forget, you shouldn't forget your maths. Maths from grade R is even important. So mine, and then what do we factor out? Please help me. I need help, guys. So what do you factor
I
out
think
there?
W squared R sine theta.
Okay. So W squared R sine of theta. Then what do I remain with?
-1
Mm-hmm.
minus 4 over n
Mm-hmm.
cos of theta.
Cos of theta cast the 0. Okay.
Yes.
Then what? Someone might say it doesn't look like the study guide. It's still fine. We chose to write it like this. Right? Right? Guys, I don't know why is the screen moving. Who doesn't want us to do our work? Who is tired? Someone is sleeping. That's why maybe our screen is moving. -1 minus 4 over n cos of theta. So then what do we do?
Is it possible to equate the two things to 0?
Yes. So we're equating. So for this whole statement to be equal to 0, this part must be equal to 0, or this part must be equal to 0. So then we have W squared R sine of theta times, isn't it? It's times here, so it's equals to 0. Or we have negative, okay, I don't know why I'm putting -1 minus 4 over n cos of theta is equals to 0. Are we all together? Then what's the next step? What's the next step?
I think we have to solve for theta now.
Okay. Let's start here. Let's start there. Someone is not muted. Let's start there. So it will be?
We divide both sides by W squared R.
Thank you. We divide both sides by W squared R. W squared R. So then we remain with sine of theta is equals to 0. And then on the other side, or what do we do?
We transpose -1 to the other side.
Yes. Which, okay, becomes +1. And then we divide by -4 over n. Divide by -4 over n. Then cos of theta becomes n over -4. Are you all okay?
Yes, ma'am.
Okay. Now, there's information that we give. What is the value of n?
It is greater than.
Thank you.
Ma'am, can't you mute this guy with the mic on? Can't you mute him because it's a bit distracting.
Okay, who's this guy? Let me mute him. Let me disable his mic. Yeah, he's no longer going to talk. Okay, there we go. So now, there in the instruction, they say n should be what? Should be greater than 4. Are we all together?
Yes, ma'am. Yes, ma'am.
Okay. So now that we found sine of, okay, my pen is changed, sorry about that. Sine of theta equals to 0, ne? Or cos of theta is equals to negative n over 4. We are given that n is greater than 4. So then what do we do?
We
What
take
do
the negative sign of theta
Well, look.
on the left-hand side there.
Which part?
For sine theta, ma'am.
So we check we check what?
We take the negative sign of it, of the 0, and then we should be left just with theta.
But remember, we are finding the theta values for which this is equals to 0, or sine is equals to 0, meaning that we are finding degrees for which when we substitute, we get 0. Guys?
I think he's trying to say the arc sign.
Okay, so if you find the arc sign, what do you get? When you find the arc sign, what do you get then?
Sine is 0 at pi and the what? At
When you
50.
find the arc sign, what do you get?
Isn't it a 0? Theta equals to 0. Ah,
0.
So that's the only answer.
Plus
That's the only answer, guys.
plus 2 pi n, ma'am.
So then how am I going to find, because you're saying plus what? Plus what?
Plus 2 pi n.
Plus 2 pi
Or,
n.
or k, let's put k because the n is gonna confuse the other n.
I just want to do something. I don't want this. I want to be able to choose. Okay. Okay, wait, I don't want this. I'll tell you what I'm doing here. I'll tell you what I'm doing. So you're saying that we find the arc sign, find the reference angle, and then you say whatever we find, we say plus 2 pi n. Won't that give you the general solution of all the solutions you think will be possible? And not the exact value of theta.
Okay, yeah, that is the general solution. Sorry.
Does it make sense, guys? Does it make sense what I'm trying to say?
Yes, ma'am, because it's already have a restriction.
Yes, it has a restriction, and it will give us what's this? It will give us the general solution. So if you use the general solution method to find it, then you're not finding the value of theta. That's what I'm saying. So what do you think we are doing? Hello. my good people. I'm talking to you.
Can we put the general solution, but then we specify that n has to be greater than 0? Is it allowed?
We can't do. Okay, let me do this first. If you're saying let's say if you're saying what is arc of sine 0? This is what you're saying. You're saying theta is equals to arc of sine 0. Isn't that what you're saying? Plus 2 let's say 360 degrees, which is 2 pi, 360 degrees times n, when n is a integer, right? Do you agree if I choose n is equals to 1, I have 360 the answer for theta?
Yes, ma'am.
If I choose n is equals to 2, n is equals to 2, what do I have? I have 270 for theta. Does it make sense, guys? For the general solution. Hello?
Yes,
Yes, ma'am.
ma'am.
I think I see what we're getting at there.
Yes. So now, I don't know, maybe there's something we are missing here. What is this piston? Let's Google it. What is this piston? And how does it work? Because if I'm going to look at in general, right? And I'm assuming because it's forming an angle, so I'm assuming it's a circular thing. Am I lying? Maybe.
Only the
I don't think
mechanical
it's circular.
engineers would know.
I don't think it's circular, but I think it moves back and forth. And I tried to Google the reciprocating engine, whatever. I think it's an engine with multiple pistons going back and forth.
Okay, let's see. Where's the piston? I want to see the piston. Because then if we understand the structure of a piston, then it means that we might understand. So this is a piston. Is there a video? But I think maybe engine piston. We not understand the question. And it's forming an angle. Oh, guys. Okay. There's another video of the piston.
Look at the one that says how does a 4-cylinder engine works, I think. Yeah, I think this is a piston here.
So if it, then it moves in a what?
An
In
up
a
and down
circular
motion? Yeah.
It moves in a circular motion, right? Now, if you were to move,
Not sure. The last part, I don't think is a piston. The
What
thing
is-
at the bottom that is a little bit circular. I'm not sure if it's a piston or it's a crank. I'm not sure.
oh, okay. So
Yeah.
if we look at, let's look at this, guys. I just want us to look at it. I just wanted to look at it. If we look at, by just looking at that, do you think this question talks about, even if we will say the piston is actually the top part here? The previous one, let's see. Here's a piston, isn't it? Because that's what they're saying. Do you think it will be over a certain angle?
If I think if you're only looking at this thing that goes down, yeah, you can see when it goes forward, because they are saying that engine is the one is an engine with multiple piston going back and forth.
Yes.
Yeah.
So I'm
So when
thinking,
it
so for this sign to be equals to 0, do we have to use 720, the angles? Where do you think we need to draw the line then? With angles, because we can't use the general formula. No. When a crank, what is a crank?
Yeah, I think that's what we need to find out. If it's the bottom part. Or maybe
Okay.
just-
Yeah, I think the crank is the one that is rotating. The one
The
that
crank is the one that is rotating.
yeah, that is moving with the circular motion. Yeah.
Yeah, I think so.
Let's see. Should you say crank in a car? I don't know.
Crankshaft.
Hey, no, a
Engine
crankshaft, yeah?
crank. Just say engine crank. Engine crank. A four-cylinder, 4-piston engine crank.
Engine crank. Let's see if we put a crank there. Because now the crank is the one that is making a rotation in this case. So are we saying the crank is this one?
Yeah, I believe it is, because I think there was somewhere in drawing class where you needed to draw a crank. I think it looks like that. That lower
So
part.
then it's the one that is making the motion, forming an angle. So it means it's moving a circular motion. Is that what we are agreeing?
Yeah, I think.
So if
Yes, ma'am.
something moves in a circular motion, what does it mean for, what's this? What does it mean? The angle will be between 0 and what?
360?
360.
360.
360.
So if the
360,
angle is between 0 and 360, so are we allowed to use the general solution where we have theta is equals to 720?
I think it makes
No.
sense, man. Huh? I
Wait,
thought it-
720?
Guys,
We are not allowed to use the 720.
then where are we ending then? So it means that since we are not allowed to use the 720, we need to use 360. Sorry. Then it means that our upper bound will be what? Will be 360. Right?
360
Our
and
lower
0,
bound
man.
will be 0, isn't it?
Yeah.
So we need to
Yeah.
find values between 0 and 360 that will form what? That will form that such that when we take them, we substitute in there, they give us the angle of, what's this? When you say sine that particular angle, it gives us what? It gives us 0. Does it make sense now?
Yes.
Am I losing
Yes, ma'am.
someone, guys?
Yeah, mathematically it makes sense, but this is a very specific question.
I'm saying that, isn't that they say the crank is making an angle? So if it's moving in a
Yeah, I think
circular
this makes
position,
sense.
yes, because
Yeah, I think
remember
it makes
that one,
sense,
there
man.
was a piston here and there was a crank that was moving in a circular path like this. This was a piston. And this was, I don't know what. And there was a crank here making an angle in that video. It was making an angle. So if that crank is making an angle and something is moving in a circular position, we can't use the general formula in this case, right? So maybe we need to focus on between 0 and 360, because if I move in a circular motion here, this is between 0 and 360. So we need to find values such that our angle there is what? Is between 0 and 360. So which values are those? What is, if I use a unit circle here, guys, what is this? One end? 0. Here is what? 0 and 1. Here it's -1 and 0. Here it's what? It's 0 and -1. And I know the first part is cos of theta, the second part is sine of theta, right? So meaning that sine of theta here is 0. So meaning that the first part will be 0 degrees. Here, the first part is cos of theta, sine of theta. Sine of theta here is 1. So this part is not okay. We come here. This is -1 and 0. Sine of theta here is 0. So this is 180 degrees. We come here. The first part we know is cos. The second part is sine. Here, sine is negative. We come back to 360. We know that it's 1 and 0. Therefore, it's 360 degrees. And these are the three values that you can focus on currently. If you then go 370 and what, you're just repeating this. Basically, you're just repeating this. Are you all together?
Yes, ma'am.
Yes, ma'am.
Okay. So now that we found those values, so we're going to use these values to find, instead of having a lot of values where you even have 37, 27, 37, and whatsoever. So we use these three values. Then, now that we have found three theta values, what do we do? Can we find theta values for this for now?
Yes, ma'am.
What would it be? What would it be, guys? So it means that it's important we understand the question, but what would it be? The theta values for those ones? Hmm? Okay, let's continue with this one. We now found that what's this? We now find that sine of theta equals to 0 at 0, 180, 360, and other values. In this case, it might be, what's this? 720 and whatever, but let's focus on these three. Now that we have found the theta values, what do we do with these theta values? How do we check if these theta values consist of the maximum or minimum? Guys, am I confusing you?
A little, ma'am, but
A
I think we
little bit,
substituted
ma'am.
back into the formula.
Remember, we found the first derivative, then we found the theta values. Now we need to go check if these theta values gives us maximum or minimum position. How do we do that? We know this is our first derivative.
Second derivative, I think.
Thank you. So we go and find our second derivative. So in this case, our second derivative is what? What is our second derivative? Guys, what is our second derivative?
It's going to be negative W squared R, the cos of theta, minus okay, it's going to be like 2W squared R over N, then the cos of 2 theta. Then we multiply 2.
Well done. Okay. Then what do we do? What do we do? What do we do?
Mom, do you substitute theta?
Thank you. So we go for the first one. Let's do this part here. We substitute theta. So we have theta is equals to 0. If I substitute theta is equals to 0, what do I get? I get w squared r cos of 0 minus 4w squared r over n cos of 2 times 0. What do I get?
Mom, you forgot to put the negative next to the first term.
Thank you. What do I get then? What is cos of 1? I mean cos of 0. It's 1. Ish,
Is
already
one.
gave the answer. Minus w squared r times 1 minus 4w squared r over n. Is this positive or negative? Guys, is it
Negative.
positive? Negative. Why?
Because both of them have minus signs in front.
Yes. And they also told us that W is positive, R is positive, N is positive. So meaning that all of them are positive. Therefore, because of the negative, it makes them negative. So it's less than 0. So this gives us what? A maximum at this point. Are we all together?
Yes, ma'am.
Okay. Now, if theta is equals to 180 degrees, what do we get? I'm waiting.
The cos will be minus 1.
Okay. So this will be minus r squared r. So it becomes positive. Then
It will then be plus the other term, 4w squared r over n.
would it be plus?
Yes, ma'am. Yes, it would be.
Would it be plus?
Yes, ma'am.
So it's plus 4wr.
No, it minus because of 2 times 180 is 360.
Thank you. So it's minus 4wr over n r. It'll be positive or negative? And why? Would it be positive or negative and why?
I think it will be positive because n has to be bigger than 4. So the
Yes.
second term will actually be quite small. So it should be positive, I think.
All done. So this is where the minimum lies. Did that make sense, guys?
Yes, ma'am. Yes, ma'am.
Then theta is equals to 360 degrees. What do you think the answer will be?
The cos will be equal to 1 in this case.
So then, should I substitute? Let me just substitute. 360 degrees minus 4w squared r over n cos of 2 times 360 degrees. So then the cos will be?
The cos will be 1, so I think this will be another maximum point.
Okay, so negative w squared r 1. Is it negative on the other side as well?
Hold on a moment. Yes, it should be negative, ma'am.
So then this will be less than 0, which is also another position for the maximum. Now, we are done with this one. Let's come to this one. Let's come to that one. How do you think we'll do that one? Guys, how do you think we'll do that one? Look at it. So we have that our second derivative is equals to what? Negative w squared r cos of theta minus 4 w squared r of n cos of 2 theta. Are we all together there? Now we want to substitute what we had before, which is cos equals to negative n over 4. Cos is equals to negative n over 4. So we want to substitute cos of theta is equals to negative n over 4. And we are given that n is greater than 4. How do we do that? Let's think. All right. You know, we even surpassed your time. Come, guys.
Ma'am, what if we substitute values that are greater than 4? Maybe we take 5, 6, and 7, 3 of them, then try to find the value of theta there.
We will not find the value of theta. Why?
Ma'am, if we substitute it the way it is.
Okay, let's start there. Before that, we substitute the way it is. Why don't we? Why are we not going to find the value of theta? If we choose n greater than 4, what is the range of cos theta?
Minus 1 and 1.
Yes.
Right.
And if we take any value greater than 4 there, do you see that we'll have something else? If we take 5, for example, we'll have 1 comma something, which is not in the range of cos. So then we can substitute the way it is into the formula. The person who says substitute the way it is, how do I do it?
The way it says cos theta, you're gonna put negative n over 4.
Okay, and then where it says cos 2 theta? What do I do where it says? Yes?
I think we should define that 2 theta to make it 2 cos squared theta minus 1, if I am not mistaken there.
Okay. You mean we use the identity. So let's do that. So we should bear in mind that cos is between negative 1 and 1. So then d squared a over d theta squared is equals to minus wr cos of theta minus 4w squared r over n. So this, you're saying we should say 2 cos squared theta minus 1. Are we all together? Yes or no? Am I losing people? I know it's a long question and it needs in detail. So then we can substitute this, right? So that it helps us to evaluate. So then this is minus w squared r. We know this is n over 4 minus 4w squared r over n 2 times negative n over 4. It's squared because of the square, minus 1. Are we all together up to that point?
Yes, ma'am.
Okay, so let's
Yes, ma'am.
simplify this. Now, if we simplify this, I don't want to get lost, guys. I'll need your help. So this is w squared r n over 4 minus 4w squared r over n. This is squared, so it's 2n squared over 16 minus 1. Yes or no? So far, so good.
Yes, ma'am. Yes, ma'am.
So we can multiply this inside and this inside. So this is equals to w squared rn over 4 minus w. Okay. I'm missing something here. This is 8 times 4. So that's 8w squared rn squared over 16 plus 4w squared r over n. So this is equals to w squared rn over 4 minus this. So it's equals to w squared rn squared over 2 plus 4w squared r over n. Okay, if I factor out, what am I factoring out? I have a w squared, I have w squared, I have a w squared. W squared r, then I have n over 4 minus. Yes, am I missing something?
With the part where it said 2n squared over 16, and then on the other side it said 4w squared r over n. Doesn't one n cancel, then it's left like n only?
Thank you. Thank you. So this n, thank you. So then it will be what? It will be n over 2. Thank you. Plus 4 over n. Okay. Now, do you remember how to simplify what's in the bracket? I'm assuming we remember, guys. Hello? Guys, I'm assuming we remember.
Make it a whole fraction.
Yes, so we remember how to solve it, isn't it? I don't have to go into it. Guys, I don't have to go into it, isn't it?
Yeah, I think it's fine, man.
Okay. So meaning that on top it will be 2n squared, right? Over 4n minus n squared over 4n plus 8 over n. Is it 8? Why am I confusing? 4 times 4 here, it's 16. So it's 16 over 4n. You guys said you are fine on how to finding it. So this is 2n squared minus n squared plus 16. Over 4n. There's something I'm missing here. So it's w squared r. So this is, okay, so this is what? This is, guys, I need your help. I'm lost. So this is wn squared n over 4 minus n over this. So if I say LCD is 4n, so this is 2n squared minus this. So here I'll multiply by 2 times 2. So this should be 2. Yeah, man, what am I? Guys, I'm getting lost. I need help. Hello?
Yes, ma'am.
Are we no longer here? Okay, so it's W squared R. Now, the LCD should be 4n. So for me to have 4n at the bottom, I'll have to have n squared and 4n. Minus, for me to have 4n, I have to have I have to have 2n times 2n. So this is 2n squared over 2n, 4n, then plus, for me to have 4n, I need to multiply by 4 over 4, which is 16 over n. So then this is equal to double R, then it's n squared minus 2n squared plus 16, should be 4 here over 4n. So this is equals to W squared R minus n squared plus 16 over 4n. So let's see if this is okay. That's where I get. Let's see if it's the same as the one in the textbook. Okay, so alrighty. So from the textbook, they took out the negative W squared n squared minus 16 over 4n. And that's the answer. Did I miss anyone? Guys?
Ma'am,
I was just huh? You say?
To the negative 2n squared.
What did I what?
What happened to the negative 2n squared? Did we factorize further?
No, it's n squared minus 2n squared, isn't it? You mean this negative 2n? This one?
Yes, ma'am.
Isn't that we added by this n squared?
Oh, okay, ma'am. Thank you.
Yes. So then it becomes n squared minus negative n squared plus 16. And then we take out that. I forgot an n here. Forgot an n here. Yes. So then we have that. So what can we conclude about that, guys? I did the calculations. You need to do the conclusions. What can we conclude about that?
It'll be negative, ma'am, so it'll be a maximum, I think.
It'll be negative. Why are you saying it'll be negative?
Because it's a multiplication between the minus W squared R and the second term.
Okay. Now, you're saying it'll be negative because there's a minus W squared R times the second term. Now, let's not focus on the first term then. Let's focus on the second term. When would it be negative? And when would it be positive? So if I choose n is equals to 4, what happens?
Then it will be negative, ma'am.
Let's go back to the top part. If I choose n equals to 4, what happens here? Let's start there.
It's negative.
Negative what?
Negative 1.
And what is the cos of negative 1?
It's 180 degrees.
So meaning that for n is equals to 4, cos of negative 1 is 180 degrees, meaning theta is equals to 180 degrees. Do we not have the value of theta that is equals to 180 degrees already?
We already do.
Good. So then that is part of the theta. Now, if we choose n greater than 4, what happens? If we choose n greater than 4, what happens?
It doesn't allow us, ma'am.
It doesn't allow us. Why? Because of this range over here. That cost has to be between -1 and 1.
Yes, ma'am.
Now, if we choose n less than 4, what happens?
We run into a problem, ma'am, because n can only be greater than 4.
If we choose n less than 4, yes, we are going to run into a problem because n has to be greater than 4. But if we choose n less than 4,
We do get values, ma'am.
we do get values. But now, since we get values, if we substitute into this expression and choose n less than 4, would this expression be negative or positive?
I think it'll be positive, ma'am.
Why?
Because if we say that n is, for example, 3, then it'll be 9 minus 16, giving us a negative value for the second term, which then multiplied by the first term will give us something positive.
Well done. So this will be greater than 0. So meaning there is a minimum extra. What's this? Isn't that we said greater than 0 is equals to? It's a position of a minimum. Meaning there is a minimum at this position as well. Here, for this value. There
So
is a minimum.
we don't consider the negative W2 squared R when we're looking for the minimum or maximum for this.
You will consider it because remember we looked at 4 scenarios. We're saying that if, isn't that they said, okay, what did they say? They say n in practical, meaning that in practical, as in like, what's this? When it's practical, when the engineers, the mechanicals are considering in real life, n has to be greater than 4. That's what they are saying. Right? So they're saying the length connecting the rod is divided by r, and in practical, n has to be greater than 4. But we come back and say, okay, now if we choose n is equals to 4 and substitute it in here, if we choose n, we're looking at the values of n now. If we choose n equals to 4 and substitute it there, we notice that that will give us -1. And we know that n is equals to 4 gives us -1, and the cost of, what's this, the arc cost, sorry, the value of theta for which we'll get -1 is 180. And we already have it from the first set where theta is equals to 180. That's fine as well. But then we go and also consider the value of n where is greater than 4. If we consider a value of n that is greater than 4, then this particular part, of course, will be unpractical because we know that we'll have cos theta is equals to -1,5, for example, or 1,0 something. And we know according to cos, the range is between -1 and 1. So we can't consider the value of n greater than 4 for this particular solution. We can't consider that for this, not for the entire problem, but for n equals to 4, for this solution, we cannot consider it. But for n is equals to less than 4, we do get values, right? Since we then do get values, meaning that we can use that to look at our solution that we have found. And if we get n equals to -4, answers here, if I choose n is equals to -4, if I choose 3, the answers here, when you get them, they'll be negative numbers, -5, -0, and if you take that negative something here, multiply by this negative something here, it gives you positive. That's why we're saying then this entire expression will be greater than 0. So we are saying there is a minimum expression because of what? Because of this. Acceleration. Why am I saying expression? Does it make sense now?
Yes, ma'am. Thank you.
Thank you.
Yeah, it makes sense.
So meaning that they then said, okay, fine, because here they said we want Find the values of theta for which A will have a maximum and a minimum value. So we're looking at the values of theta. Are we all okay now? No, it was a mouthful. Any question? Guys, any question?
So, ma'am, what happens in the exam? Because we won't have Google and we won't know if the machine or whatever it's in a circular motion or what's going on.
In the exam, is the recording stopped?
No, ma'am, it's still going.
I'm stopping it. I'm not going to answer in the questions for the exam in class. Okay, let me just answer. In the exam, I won't give you a question where you don't even understand what is. Are you all together?
Okay, ma'am. Thank you.
So
Yes.
I'm curious. So you were the one that made the study guide, right?
No.
Oh.
The previous lecturer made the study guide.
Oh,
Me,
I
I'm
see.
making the study guide for 2027. From
Oh, I see.
2027, yes. Let's see. How do you stop recording? Now I don't even know how to stop my own recording. Okay. So the question is